Okay, so the first thing I do is this, is I'm going to say the letter n, the number of time compounding, is equal to some m times r value. And I'm going to do a substitution. So I'm going to say a of t is equal to the initial value, a naught, times 1 plus r over, and then here's where I do the substitution. I'm going to put in m times r, where that n was, and the n up here, I'm going to put an m times r as well, times t. What you're going to see is this. You're going to see these two reduce out, and I'm going to do something with parentheses. I'm going to put parentheses around from here to here. So let me rewrite this now. This simplifies to a times t is equal to a naught. And then in this red parentheses, it's going to simplify to 1 plus r over m to the m power. And then notice you still have the interest rate up here in the exponent times t. This right here is just some algebra. Also, the rule that's going on here, just by way of examples, this is, we learn an exponent rule, a to the m to the n power. Oh, I'm going the other way though. Is this, let me go the other way. If I do a to the m times r power, that's equal to a to the m to the r power. You know, and if you want to do this, you know, kind of with your calculator, you know, it's this. On your calculator, if you do like 3 to the 6 times 4 power, actually, that's a big number. Let me make these smaller. If you do 3 times 2 times 4 to the power, and then down here, you do 3 squared to the second power to the fourth power, you'll see that if you type this in your calculator and this in your calculator, you will get the exact same number. Okay, they're equal. Okay, so that's kind of this algebraic exponential equivalence I'm doing here. Now, here's the key. You can see, and I'll pick yellow, how this right here looks exactly like that expression, which is the same thing as E. So in other words, as m approaches infinity, as m gets really large, this whole thing gets close to E. So I'm going to now rewrite it as a to the t is equal to a naught times E. And then notice, I'll keep it in blue, rate times time. Okay? So this right here is what's known as continuous compounding. Okay? And if you want, by way of going back to this example right here, we can plug 500 here, 4.5 in the exponent, and use E in your calculator. So you're going to do this, 500 times E to the 0.045. It's still over 2 years. And what you're going to find is this number right here is going to be just a little bit bigger number than right here, which is going to be bigger than this number right here. And, but not by much, but this, because the compounding is approaching an infinite number of times. So it's not 365, it's not 10,000, it's not 1,000,000, it's not 1,000,000,000. You know, this right here is how we get this idea of E, okay? And how it applies. Super, super important. And this is a formula now that we're going to use a lot for between now and the end of the year.